Hello and welcome to another C++ video. So today we're going to be going over functions. So last episode I used Visual Studio, and over the next few episodes I'm going to be using a few different editors just to show you the different options that are out there for coding in C++, because Visual Studio might not always be the best option. So today I'm just using Visual Studio Code. You could use any text editor here in replacement Sublime, even Notepad. But I like Visual Studio Code, and it's really popular. It's a good editor. So I'm going to be showing you how to compile programs in the command line today, alongside writing functions. So the first thing I want to talk about is last episode we covered the basics, and one of the key fundamentals in writing good C++ is functions. So what are functions? Functions are bits of code that can be reused, if you like. They mean that they're sets of code that can be called and then executed many times without having to rewrite them. For example, if I had a function to get user input and then print out whatever they're saying, I just have to say get user input and print, assuming I defined that function, and I could run that. I could say that 100 times and it would work beautifully. But obviously, we have to define the function first. So in C++, defining a function is kind of a double-barrel process. So the first thing you have to do is you have to initialize the function, and the syntax of that is fairly simple. First, you have the return type. So this is the type of data that the function will return. So as you can see, and I said last episode that I'll go more into this with the int, but as you can see, int main means it has to return an integer, thus we return 0. We could return 1 to 100, whatever, minus 100, it would all be fine. But if we then returned hello or h, you see that the code breaks. So when we're initializing a function, we have to include a return type. So void is you're not going to be returning anything. Int is obviously to return an integer. Float is obviously to return a float. Char to return a character, etc. So now let's get started programming functions. So we're just going to create a function that gets user input, that gets the user's name and prints the user's name. So this is very easy to do. So all we do is type in void because we're not returning any data, and then we type in the name. So print user name, and then there's no parameters, and that's this line of code done. Okay. Now you'll notice that if I go down here and go print user name, I don't get a little red line under it. Well, there is because no semicolon. But that means that's all ready. So now I can go down here and I have to now define the function and say what it's going to do effectively. So I type in void print username, and then I open the curly braces. So it's the exact same syntax as here, just to have curly braces there. And now I can type in what I want. So if you remember from last episode, we want to start off by holding a variable, and strings are a little bit complicated in C++, and I'll be going more into them. But for now, we just want to go #include string. So now we can use a string data type freely. String. Maybe it's string. Yeah, maybe it's just that. There we go. #include string name. Oh, so we initialize the name variable. Go away, speech recognition. So now what we want to do, go away, is prompt the user to enter your name. And now remember, we don't want to use end line because we want the statement to be on the same line. So you can just put a semicolon there. And then cin, and the input stream operator, and name. And now we're going to write cout end line, so it's no longer on the same line as this, as like the enter your name, and then if we didn't have that end line there, this would be on the same line again. So it'll be enter your name, Oscar, hello, Oscar, all on one line, which would just be crazy, and I wouldn't want that would just look horrible. So now I can type in hello, then space, then name, then end line. So now, when we call print username, if I go C++ functions.c, so that's the syntax to compile it if you're using command prompt. So assuming you've installed the C++ command, you just type in C++, the name of the C++ file, and then it will generate an exe. So you can go here and I can run A and enter your name. My name's Oscar. That is because quickly what we want to do is we want to create int. So the second it printed, it just executes it automatically. This is fairly easy to solve. You just go int placeholder, cin, and basically what this tells it is to wait. All this is telling it to wait for a keyboard event before entering. This is just a little extra bit of code that you have to do. And if you're doing it like this, it just makes it. I'll look into different ways to do it. I normally use code blocks when I'm writing C++. Try it now. Now it should run. Everything's working fine. And I imagine if you're on Visual Studio, yeah, there we go. Hello, Oscar, and that's a function. The beauty of function comes if I wanted to do this multiple times now. So say I wanted to do this twice, I wouldn't have to write that code out again. I can just do this, which is a lot more concise. So you can see there that functions generally make code conciser and easier to read. And where functions are really useful is breaking code down in a type of computational thinking called decomposition. So in this type of computational thinking, we will break a big problem down, like, I don't know, making a game into many smaller things. So it might be walk, and functions are key in this because they allow you to really get an overview and then go more and more detail, and it's really brilliant. And they also make your code easier to read. They make your code easier to write for you. It's just really worth doing. As you can see, it saved us a ton of time. But you're probably thinking, okay, what if we want to say we want to be able to introduce ourselves? So let's create another function. Okay, so I'll just comment this out. So comments in C++ just // and this means that whatever's on this line is now no longer going to be ignored by the compiler. So it's just saying, yo, this line, ignore it. And it can be used if you don't want a bit of code to run but don't want to delete it, for example. So now I'm going to be talking about passing parameters. So parameters, so when your computer gets a parameter, what it does, a parameter is a variable that's passed to the function that it can use. And what your computer will do is it will copy that into a new variable, and then it can use that. The key thing to remember is that it will not use the same, it will not be the same. Whatever you do to that localized variable within the function will not actually happen to the real variable. And I will show you proof of that as we're coding. So once again, we want this to be a void. So we don't want to return any data type. Now I can go introduce myself. And now to pass in parameters, here we just type in the data type that the parameters are going to be. So I want to just have a string. That's all I'm going to write. However, when I get down to here, I'm going to do exactly the same as last time. So I'm going to type void introduce myself. It comes up there. This time I'm going to type string and then the name that we want to treat that variable as throughout the rest of the function. So in this case, I'm going to call it my name. Then we can write the code out. So we can go my name. So you can go just copy and paste this code. And now all we're going to put is hello name I am, and then we're going to get it to print my name. This just makes your code. So as you can see here, I'll show you what this code does now. Make sure it's saved, and now run it. Now if we go to the code and run A, I'm not calling code. I'm not calling it. Am I? No, I'm not calling it. Silly me. So you have to call a function, and the syntax for calling a function is fairly obvious. It's just the function name. So introduce myself, and then brackets, and within these brackets you pass all the parameters. And in this case, it's one parameter, which is name. So in this case, I'm going to say my name is Bob. So we're getting an introduction from Bob. So if I compile this again, go into file, go and run the exe, enter your name, Oscar. Hello, I am Bob. And the good thing about parameter is that we can change it. So we can say Sam. Hello, any Sams out there watching? Oh, I need to recompile it, didn't I? Run the code. What's wrong with the code? Oh, it's running, that's why. Silly me. So now I can go into here and I can run the code, enter your name, Oscar. Hello, I am Sam. So as you can see, that's pretty cool. So now, as I was saying earlier, the my name variable, okay, is not the same variable as the one that we pass in, okay? So if we create a string name equals Sam and you can also obviously pass in variables into as parameters, so like name, and it works the exact same, but the key thing is the variable that you pass in must be the same data type as the parameter is. So if it's a string, the variable that you pass in has to be a string. So now we introduce ourselves with the name, but so now if I print out, so what I'm doing now is I'm going to print out quickly the memory address of and name and line. So this is a reference, and references and pointers. This will be more. We'll cover this when we're covering references and pointers, and basically you can view the memory address. So if I print out, so cout and my name, and what this prints out is the memory address, so the place it's stored in memory. So if I close this and compile, you'll be able to see, Bob, that these two are not the same, which means they're stored different addresses in memory, and that is really important to know. And as we get into more advanced programs, you'll start to see why this becomes a bit of an issue at times. But also at other times why it's really good. But the key thing is to remember that parameters are just copies of the variable that you pass in. They're not actually the variable that you pass in. So you're not manipulating the variable. So the next thing is all of the functions that we've written today have been returning type void. So what if, say, we want to get the user's name and just return that as a string? So if we want to do that, it's fairly easy. We just type in string instead of void, and then get user name, and then we don't want any parameters. And what's the point of a parameter if we just a bit pointless? So now we can just go string get user name, and now we can go cout or string name, So we're just initializing a variable called name, and now we're going to prompt the user, enter your name. Now we're going to go cin and write a variable to name. So whatever the user inputs is now inputted to name. And now I can go cout, not cout, what does it say, end line. Hello. So just going to say hello, their name, and then we're going to end line again. And we're also, while we're here, I think we may as well return name. So now if I go here, I can now print out. So now what I can do is I can set a variable name. So I'm going to create a few name variables here. So I'm going to have string name 2, string name 3. So now I'm going to create a few names. So I'm going to create name equals get username. So now what this is saying is that this return statement basically outputs the value at the end of it, and we can set variables equal to that value. It's just it's really, really fundamental in programming. So it kind of gives it back, if you like. So you run the function, and then it spits out whatever we return, and the computer can use that. Make it a bit nicer. And the computer can use that, and then we can set that equal to a variable, or just use it in a calculation. It's just really worth doing. Sorry if I'm not being very clear in these videos. If you're completely new to programming, though, C++ probably isn't the best language, so I assume most of you at least have some programming knowledge. Obviously, I'll go into more detail when it comes to objects next episode. So now from here, what we want to do is we want to have name2 equal get username. Name3 equals get username. So now we get the 3 usernames. If I just go compile this, my bad, compile. So now I can jump in to here, I can run it. So enter name, Oscar, hello Oscar, Sam, Bob. So now, of course, I forget to print out the values. So now we can go down here and we can go cout, name, cout, name2. One doesn't make very much sense. Cout, name, my bad. Sorry about that. Name3. Name3. Okay, so now if I just quickly compile this, you'll see that we can run this, jump into it, run it. Bob, Sam, Jeff, and now we have name equal Bob, name2 equals Sam, name3 equals Jeff. Sorry for that horrible formatting, but you get the message. So return types are used when you want to set, when you want to get a variable and set it equal to something from a function. Hope it makes sense. So if you want to use a function to spit out a value at the end and then set a variable equal to it. Another thing I want to talk about while we're here, because we've been using strings in today's episode, but strings in C++ are a little bit funny. In fact, I'll just create a new file for this. There we go, strings.c++. So strings in C++, strings in general are not a fundamental data type. They're an array of characters. The next episode is actually going to be all about arrays. So you will get more, so you will learn more about arrays in that episode, but the key thing to remember is that because they're not native, you need to use a library, a preprocessed directive even, sorry, a hashtag include string. Otherwise, if you don't want to do this for any reason, you can just use a character array. So if I just create a int main, just run some code. So character array. This is the syntax for making an array. Once again, don't worry about this too much now. We'll go into more detail about it next episode. Name array equals B O B. Then we use a special character to make a name. And let's see. That's wrong. Yeah, I've done this wrong. It's name array. There it is. That should be right. Yeah, that's right. And it's so I've been coding quite a few languages right at the moment, so it's a bit weird. And it's all single quotation marks as well. I've just been coding a lot in Python, so some of my syntax might be very Python-y, and I'm sorry about that. I'm working on a Django thing, but you know, C++ is just a bit different. So this character at the end is a special character that tells C++ to treat this character array as a string, but don't worry about this. Is showing that it's not a native data type. So if I go cout caret array, then I just get it to output array and line. You'll notice that when we're writing, what's wrong with this? Oh, of course, using. I bet you some of you are thinking I didn't use namespace std. Once again, we always have to include that if we want to do output. Or we can just specify the namespace each time we're using functions in the namespace std, but they're just cleaner. We can also, but that is, you might be thinking this is a lot of hassle just to write a name. So for now, just do hashtag include string and string in angle brackets this line if you want to use strings, and then just do string name equals Sam, and then we can do cout string, and then we can go Sam. Sorry, my bad. Name. I feel like we should go into more detail on this topic because I believe it's fairly fundamental in knowing unknown escape sequence. What's going on? I don't use that syntax very often, so I'll just check. This is very confusing. This was a bit of a unplanned section of the video, so you know, stuff does go wrong. My bad. It's 0, not O. My bad. I was just checking there what was wrong, and it was that it was a 0, not an O. Okay, so now if we go and we just quickly reveal an explorer, let me just jump in. I'll just add that usual return 0 and a placeholder quickly to make it hold. So int p cnp. So now I'll just go compile it. And now I jump into here and run a. Now it should run. So as you can see, they both look exactly the same, other than the different names. But it's just worth noting that ultimately all a string is a character array. Therefore, it's not a native data type, and you have to include it. So I imagine quite a few of you were getting quite annoyed when string wasn't working, because above all if you're coming from a language like Java or C#, where it is set like as native as integer. But it's just something worth noting when you're writing code. So thank you for watching this video, and I'll see you next time.